Oh, hydrogen chloride. Thought for a second hydrogen was in there twice. Okay. It does happen. Beautiful handwriting as ever. Okay. Hello, my name is Dr. Gleisner, and this is a practice video for dot and cross diagrams, and the specification says that you need to be able to do them for the following covalent substances: hydrogen, chlorine, oxygen, nitrogen, hydrogen chloride, which is, when it's dissolved in water, is of course hydrochloric acid, water, ammonia, and methane. So let's get to it. How do I do that? Okay. Okay. Bum, bum, bum. So hydrogen is the simplest one, because all you've got to do is, if you draw the outermost shells, draw two of them, and then you share that single electron that they each have in that outer shell. So this is H2. How do we know that's correct? Because when we count in the first shell, which is the only shell that they do have, here have some nuclei for no reason, then we've got an overall configuration of 2, which is, as the 288 rule says, a perfect outer shell. But of course, remember that that's only a share. Each hydrogen atom only has a share, and it has given its own outer electron in order to have that. Okay. Let's get rid of that. Okay. Okay. So let's do chlorine. And chlorine is element number 17. That means it has an electronic configuration of 2, 8, and 7. It is part of group number 7, therefore. It's in the third period. And it looks a bit like this. So it has 3 shells. The first one has 2 electrons on it. The second one has 8 electrons on it. And the last one has 7 electrons on it. Now there's a reason why I'm going to draw the 7th electron on that side. Because what I'm going to do now is I'm going to copy this last full outer shell, and I'm going to stick it right next to it. I'm going to stick it right next to it. Can you make a circle, please? Right. Apparently not. Finally, okay. And what we should do is we should make sure... Stop zooming. Well, what we should do is make sure that this outer electron doesn't actually overlap all that much. Now, in the exam, you're likely to get a pre-drawn diagram, probably with just the outer shells, and all you need to do is stick 2 electrons, 1 each from the chlorine. In that sense, it's quite similar to the hydrogen, but of course we only have to share 1 because it already has 7, and if you put 1 in the pot and receive 1 in the common pot, then you have a share of 2 electrons and an overall outer shell filled with 8 electrons. Now, I could, of course, also complete the inner shells for that, and I shall do that this time. But for the rest of the practice, I will then spare myself that, if appropriate or where appropriate, and just draw the outer shells. I will, however, give you the electron configuration so that you could potentially draw the complete atom. Okay, so the next one is nitrogen. That's a perfect diagram of 2 outer shells just touching. So the next one is oxygen, not nitrogen, it's oxygen. Okay, so the next one is oxygen, and oxygen has atom number 8. And therefore, it has an electron configuration of 2, 6. It's in group 6. And how many electrons does it need to share in order to get to 8? Well, if it has 6 outer electrons, it needs to share 2. So that means it has 4 that it doesn't need to share, but then it has 2 electrons that it does need to share. So either side has 4, doesn't need to share, and then 2 that it does need to share. And there we are, a perfect picture of oxygen. Okay. Next one up. The next one up is nitrogen. And nitrogen is in group number 5, it's element number 7, therefore it has an electronic configuration of 2,5. It's in group number 5, and therefore it has 5 electrons in its outer shell. That if it has 5 electrons in its outer shell, but it needs to get to 8, because that's what the 288 rule says, then we need to share 3 electrons from each one. And I've already alluded to the idea that nitrogen is very strongly bonded to each other. Oh, hello. Forgot to get rid of them. Okay, there we go. And there we have it. So the version that chemists normally draw, because they don't tend to draw dot and cross models, is this model, which is 2 nitrogen atoms bonded, where each of these sticks represents an electron pair that is shared between the 2 atoms. Okay, and therefore it is really difficult to split nitrogen up. So, next one up is hydrogen chloride. And for that, I'm going to resize this into something smaller, because it is going to represent hydrogen. There we are. There we are. Okay. So, I hope you've managed to do it. If not, press space. I should have said that at the beginning. Press space to pause the video. Okay, so here's the solution. Hydrogen chloride. Hydrogen now needs only 2 electrons in its outer shell, but it only can contribute 1 electron. So it will contribute its 1 electron, and chlorine will also contribute its 1 electron. Now, chlorine is in group number 7. That means it has 7 outer electrons. And luckily for us, that has to work out if the formula is HCl, which it is. So if we count around the outer shell, 1, 2, 3, 4, 5, 6, 7, 8. And if we count around the outer shell for hydrogen, so that's the hydrogen, that's the chlorine. Should stop doing the L's like that. You might miss a mark there if you do that. Yeah, there's another one. It's just me being lazy. Okay. Then the chlorine now has 8 outer a share of 2 electrons and 6 outer electrons, making 8. And the hydrogen has a share of 2 electrons with its own electron given to the common pot there shared between HCl. If you want to write it as a molecule with a stick bond, then it looks like this. Okay. Next one up is, what's the next one up? It's water. Okay. So since that was our hydrogen, it's going to remain our hydrogen. Oh. I'm now going to copy that over the other side. There we are. So this is now another hydrogen. And for the eagle-eyed among you, you will have spotted, in fact, that I probably should have put the hydrogen in a slightly different place, because that's a more realistic version of what water looks like. And if you're not familiar with that, watch one of my earlier videos on covalent bonding, and it'll make it apparent. Okay, so what's happening here? Well, oxygen is a group 6 element and therefore has 6 outer electrons. That means it needs to share 2 electrons in order to get to a share of 4 and owning its own 4 electrons as before. So it will share 1 with hydrogen, and the hydrogen will share 1 with the oxygen. And the good news is that if you're given a formula and you're asked to draw any of these, you know that the proportion of atoms is already correct. What you don't necessarily know is which order the atoms go in. And you could think maybe it's the O on one side and then there's an H and an H on the other side. But since H's can only share one electron, they both have to go to the O. And it's the same for HCl, although there's only one H anyway. And it's the same for NH3, which we'll come to in just a second. And it's the same for methane. So whatever atom isn't the hydrogen goes in the middle, and then you just put the H's around it. And you basically copy what I've done here. So this is water. The hydrogens, once again, have 2 electrons there, and the oxygen has a share of 4 electrons for a total of 8 electrons. So that's wonderful. And we now go to... that's turned my scribble into an ellipse. Okay. And now we're doing nitrogen. We're doing ammonia. Okay. Have you done it? Okay, here it comes. I've done that purely for symmetry. There is a reason for that as well, but it's not really important for us. So, again, it sort of doesn't matter. We don't need to think about it. We just put 1 cross and 1 dot on each of the overlapping outer shells for the hydrogen and the nitrogen. Nitrogen is in group 5, so it needs to share 3 electrons and receive a share of 3 electrons, because it then has a leftover of 2 electrons, because it is in group 5. It has 5 of its own electrons, as you can see from the crosses here. 1, 2, 3, 4, 5. Okay. And there you have it. Okay. So now we have got methane. So while you're doing that, you can press the pause button, and I will copy yet another hydrogen, because we need 4 of them. So what happens here? Pause the video, do your own work, and then come back and check it. Do this bit. Okay. So we have carbon in here. Now carbon is in group 4. That means it has 4 electrons in its outer shell. And that means it needs to share all of those 4 in order to receive another share of 4 in order to have 8. And so again, without thinking virtually, we can go put a dot and cross in there and then think about whether we need to do anything else. And the answer to that is no. We don't need to do anything else because carbon is in group 4. It has 4 crosses, 1, 2, 3, 4, and it now has a share of 8 electrons overall. And that is it. There's no more to do. So in just before the revision, you might want to go through this video again and use it as some practice, or potentially just as a flashcard. So it's a mixture of both. And I shall see you in the next video. Please like and subscribe and let me know of any questions you'd like me to cover in the comments.